Set up the definite integral required to find the area of the region between the graphs of this and this over the interval -1 to 3. So how are we going to do it? So basically, let me show you the graph, even though you can't use the graphing tool on the exam, and then I'll talk about how you can do it without the graph. So there's the graph. There's the whole story. So we have this is the Desmos graphing tool. So the y equals minus 14, y equals 14 minus x squared. That's the parabola. That's this red upside down U shape, right? And negative x squared is a parabola going down. And then the blue is a straight line. It's positive slope because only x to the first power. So it's a line. It's a positive line going up. There it is. Okay. And we want to go between -1 and +3. So here I've done, here's -1, here's positive, here's 0 right here. So there's back, no, right here. I'm sorry, here's -1, back one. So here's the -1 line right there. Yeah, in fact, I can do a little arrow if that's helpful there. Ooh, that wasn't so good. All right. There it is. There's the -1 where it starts. And then there's the +3. So basically, we're trying to find this area, this purple shaded area between -1 and +3 that's between the two functions. Notice the straight lines on the top and the parabolas on the bottom, at least in the region between -1 and +3. They change over here. Over here, the parabolas on the top and the lines on the bottom, but we're not in that region. We're from -1 to +3. The lines on the top and the parabolas on the bottom are finding the area in between. So we're gonna set up the integral to find all this purple shaded area. Okay, so then getting back to it. So without seeing that picture, how would you know all that? Well, you know you're going to integrate. Whenever it's a dx, you're going from left to right. So I'm going from left to right. Okay, and it's pretty easy to know what left and right is. This is obviously left, and this is our right, obviously right, because it's given us, and that's the x region. So from -1 to +3 of what? Well, we're always going to take the top function minus the bottom function dx. Why? Because that is the height of each rectangle, and the dx is the width. And the way you find the area of a rectangle is height times width. Or you can call it length times width, height times width, whatever you want to call it. One side times the other. That's how you find the area of a rectangle. And we're going to sum, it's a big S. We're going to sum, we're going to add up all the rectangles from left to right, from -1 to 3, each rectangle having a height times a width, and the height is the top minus the bottom. You can see it right here, right? We're going to, if I put in a rectangle right here, boom, boom, that rectangle, the width is dx. That's the width of that rectangle, how wide it is. And the height is the top minus the bottom. That'll give you the height, right? When you have that's how you find out how high something is, top minus bottom. That'll give you the height. So we're going to take the line that's on the top minus the parabola that's on the bottom. But if we hadn't just graphed it, how would we know, right? Like if you didn't graph the thing, you would know, okay, this is the left, this is the right, got it. We always need to take top minus bottom to get the height. The width is dx, we got that. But how would we know which one's on the top? Sometimes it's a line, sometimes it's a parabola. How do you know? Well, you check to find which is on the top, plug in an x value between the left and the right. Between the left, x equals -1, and the right, which in this case is x is +3. So just plug something in on that interval. What's a number between -1 and +3? How about 0? I'm going to plug in 0. Plug in to both functions. I should say to both functions. So plug into both functions. So I'm going to come up here and I'm going to grab the first function, the parabola, y equals 14 minus x squared. And then I'm going to grab the other function, the line, the straight line, 12x plus 34. Then I'm going to plug in x is 0. Boom, and boom. And so that's easy. That's easy math. That's just 14. And this is 34. So this one's clearly on the top because it's higher. That's the one on the top. So the straight line is on the top. So we go top minus bottom. We got to do the line equation here first. This is going to be 12x plus 34. That's the one on the top minus, which one's on the bottom is the other one. 14 minus x or the parabola, which is, of course, the truth. We know it. The line is on the top and the parabola is on the bottom, in that region anyway, right? For x equals 0. We plugged in x equals 0 to both of them. There and there. There we go. So then the integral becomes this minus this. You can just type it in like that, or you can simplify it. So I'll bring it down here and clean it up a bit if that's helpful. So it's, what is it? 12x plus 34 minus, and then the other one, 14 minus x squared. And then just distribute, boom, boom. 12x is 34 minus 14 plus x squared. And then you can combine those two in the middle. These guys is plus 20, right? And there we go. So the answer becomes the integral from left to right. We already know the left is -1, the right is +3. So -1 to +3 of this function, 12x plus 20 plus x squared dx. Is that the answer they got? 12x plus 20 plus x squared. Yeah, different order, but that's it. And that's how we do it. So really, it's always going to be the integral from whenever you're doing a dx, you're going from left to right, like the x-axis does, of the top function minus the bottom, because that's the height times the width. That's the area of a rectangle. We're adding up a bunch of rectangles. And you just got to find out which one's on the top, because it could be vice versa, and that'll change the answer. How do you know? Plug in some number that's between the left and the right. Just plug into both functions, find out which one's higher. Well, the line's higher in that region. And so there we go. We're not going to actually compute the answer to the integral. We're not going to find the area of all that part. We could. We did a bunch of these in earlier sections. We could do that integral. I just didn't want to make these too long. So I'm not going to do the anti and plug in the two numbers. It just takes too long. But we've done it before. There's the setup. And there we go.